All right, everyone, welcome to this month's Dr. Spotfire. My name is Neil Kanungo. I'm your host, and we're going to be doing exploratory data analysis in Spotfire. So, whether you are on LinkedIn, YouTube, Facebook, hope you're joining us from around the world today and learn a little bit about this new topic. We are going to be live streaming on all of these platforms and keeping the recording for after the session for those of you that can't join or need to drop off early. So let's go ahead and get into a little bit of our intro. Today we're doing exploratory data analysis. I'll be joined by Sweta Kotha, and you might have known Sweta from a few of our earlier sessions. Now, Sweta is with Jose. They are both actually part of our expanded team. So, Sweta, if you want to pop on and say hi and say hello to the group. Let me go ahead and add you to the stream here in StreamYard. Hey, Sweta, how are you doing?
Hi, hello everyone. So really excited to be talking about some EDA today.
Yeah, Sweta, we're happy to have you. So Sweta and Jose are going to be doing many Dr. Spotfire sessions in the coming year. So you'll see that in the rest of 2021, rest of 2022. I put these QR codes on the screen. I'm leaving those up for a second for you. Those are QR codes to their LinkedIn pages. I encourage you to find them on LinkedIn. You can scan that from your phone if you want. Find them on LinkedIn, follow them. They'll be putting out tips as well. So we have more Dr. Spotfire love in the house. So thanks again, Sweta, for joining our team. And next on the slide, we just want to talk about our December 7th session. Sweta, you'll be joining us again, and we're going to be doing regression methods, right? So you want to say a little bit about what you want to show next month?
Yeah, so regression methods are some of the most common statistical methods that any analyst has in their toolkits. It's really like we're trying to predict some type of numerical values. So we're going to cover a broad range of techniques as well as how you can use Spotfire to easily run these analyses and be able to evaluate them. This goes from like linear regression, which is kind of the basis for many statistical methods and its variants, to some of the common data functions that we have, like random forest, TensorFlow, etc.
Sweta is an expert data scientist, so in her session, she's going to be showing us more data science topics. We've got more requests for that. And today we thought would be a really good introduction to that with exploratory data analysis. So, again, our new delivery format, just real quick, we're going live on Facebook, YouTube, and LinkedIn. So you are watching right now, then you have probably found a live link, and that's great. So registration is no longer required. But if you do want to watch this after the session, it is going to be on our Spotfire YouTube channel, so you can find that on YouTube and recommend that you subscribe. So let's go ahead and get started into the session. First, some EDA basics. Now, we talked about how do we keep this session, like, EDA can be kind of a drier topic. It doesn't have all the sexy data science and statistics always in there, but it is the first thing you do in any analysis, and it's very important. Now, we're going to show you some tips. You don't have to do everything that we do, but we just wanted to give you some tips on things that you can do to help explore your data. And with that, we're going to do some basics that just everyone needs to know. I'm going to start with that, but we're also going to go into some more advanced approaches and actually some statistical approaches. So some EDA basics at first. All data is going to be divided into two groups: numerical and categorical. So on the right, I have two data set, or I have one data set here, and you're seeing this honey production data, and it's got numerical and categorical data. And this is actually very critical to building any analysis in Spotfire, as well as doing statistical analysis. Now, numerical data is very straightforward. Anything that is numbers based, and then categorical data is anything that's not numbers based. So it might be like string based. That can also be further subdivided. So numerical data can be finite, like a colony. This is honeybee colonies. There are not partial colonies. There are only whole colonies. There are only whole stocks. It can be continuous, such as the percent yield. There's infinite, you can get infinitely small amounts of yield or infinite resolution there. It's actually a continuous variable, or the price per pound. You can get fractions of a cent. So you have continuous and you have discrete. So discrete here, continuous here. You also have two types of categorical data, which is nominal, which is unordered. So like the state, there is no order of the states in the United States. So this could be just like different flavors of ice cream. I usually say like vanilla, chocolate, strawberry, no order there. And then there's also ordered, and ordered that does matter. So this could be a rating like very good, poor, acceptable, things like that, those ratings. So um, I am seeing some comments here on the chat. So I wanted to address that while I'm looking at it. So let's see here. I'm seeing some comments on the chat. So, hey, it looks like people are finding the chat. So there is, if you are having trouble finding this on LinkedIn, there is a YouTube link. That is the YouTube link. You can go to our YouTube channel, and you can also just put /live at the end, and you can find it there. If you are having trouble finding any of these sessions, there is, if you look at the TIPCO Spotfire, Dr. Spotfire session. Let me go ahead and pull that page up real quick. Dr. Spotfire office hours, and let me add this to the stream. You're going to see 4 links here, and so you can find the YouTube channel, LinkedIn group, things like that. So in case anyone's having trouble finding the link, looks like most people are able to join. Anything that you um, say in the comments are going to come over to me, and so feel free to ask your questions throughout the session. All right. So with that, let's get back to our presentation, and I'm just going to go back to showing just a couple more basics. So we talked about the data basics here. I also wanted to point out there is, if you have data that is bivariate data, you have one parameter on one side, another parameter on another axis, and that data is kind of arranged in a positive slope. That is called a positively correlated data. You can have a strong correlation where those points are really tight, and you can have a weak correlation where those points are kind of more spread out. Um, Now, you can have a negative correlation if those points are going with a negative slope, and a positive correlation when they're going the positive slopes, and those can be both weak or strong correlations. And if you have data, oops, that is actually the wrong chart, but if you have data that looks a little bit like a cloud, let me actually show you that. I want to show the right one here. There we go. So there's a right screenshot. If you have data that looks a little bit like a cloud, then that is no correlation on your data. And that's something to watch out for, because that tells you that the data you're looking at doesn't have a meaningful relationship with it. Now, the other thing to quickly chat about, I'm trying to use this getting apologies, getting a little used to the streaming. So let me get my controls here. All right. Now, the last thing to kind of talk about here is a symmetric, left skewed and right skewed. So a symmetric is going to be arranged around the center. Left skewed is where your points are going to be kind of your distribution of your data is going to start moving towards the left a little bit. Right is to the right. That's also called a positive skew or a negative skew, and that's going to be important because that's going to pull out things like it's going to pull your average out. If you have a positive skew, it's going to pull your center out from your average, and so you might want to use things like median for your measure of center. And we're going to talk about that a little bit more in a bit. So let's go to Spotfire now. Let's get out of the slides. Let me go ahead and show here is my Spotfire analysis. And I'm going to turn my little head off. There we go. So here we go. So the first thing I do in any Spotfire analysis is I just look at the data. So right here, I have a vehicle data set, and I'm looking at all the different columns of data in here, and I just want to get a sense of what's in my data set. So I want to understand, okay, there's the division like Porsche, the car line, Boxster, Boxster. There's the city and highway fuel efficiency, air aspiration method, what type of transmission. I just want to get a sense of my data. And that's why I always keep, and a little tip is I keep the table visualization shortcut in my toolbar right here so that I can easily just add another table, and I can look at whatever tables I have in my analysis. So this one only has one table in the analysis, but so I just get a quick sense of that. Another thing people may not know about is there is a summary table visualization, which will quickly give you for all the numerical data, measures of centers such as average and the median, what the minimum and maximum are, the standard deviation. So it'll quickly give you representation of just the summary statistics of those numerical values. The next thing you want to start looking at are, okay, I'm starting to see some missing data. Are there duplicates in this data? I need to be able to handle that. So duplicates and missing values, one thing you can do is, if you have a rather large data set, is you can create what I've done here, which is a heat map that shows you where your missing values are. So the way you do this is you go to heat map, the heat map visualization, and it's really simple. The top column selector, just remove that there. On the left column selector, you put row index, a row number in, and so each of these rows is now the rows of your data set. And then here, you just select columns and you add all of your columns in here. So let me actually add all of these. And now you're going to see these different colors, and what it's showing is the maximum and minimum for the numerical values, and it's showing all black for the categorical. So you really want to go into colors, and you want to take the numeric ones and do fixed, and then you can do, let's say, all values. I'll make those black, and then the empty values, I'll make them red. And then I want to add something for my numeric one, another color script screen. It's not, sorry, not for my numeric, for my categorical. So a little trick is, sometimes when you see these displays, you can sort them by your data type. And so I can grab all of my string values here, add that to a whole color scheme grouping, and then do the same thing. Where there's values, I'm going to put black, and when there's empties, I'm going to put red. And so that allows me to quickly see where all the empty values are in my data set. So that's how I built that. Now, to read the top, you can right click and turn on your zoom slider, and you can move this around. So I'm kind of zooming in here, and I'm seeing a lot of empty values in some of these categorical types. One thing I noticed was there was some empty values for the two-door passenger volume, two-door luggage volume, four-door passenger volume. And what this is a two-door vehicle has volume for where the passenger seat and where the luggage is, so the trunk. And then, of course, if it's a two-door vehicle, it's not going to have any data for the four-door. So that means, of course, that's going to be empty there. And same thing for a hatchback. And so one way you could address this is say, well, I'm really only interested in looking at the size of the vehicle, the interior size of the vehicle. I'm not really interested in seeing all of this all broken out. And so rather than having these 6 columns, you may choose to do something like create a column transformation, where you can calculate a new column. And in this new column, you might want to say the sum of your passenger volume. So let's say I can just type in volume. Let's say uh, I'll just do the sum of all of these, and that's going to take either the passenger, if there's it's going to take the passenger volume and the luggage volume. And if it's for two-door, there'll be data, and when there's four-door, there'll be data, and if it's a hatchback, there'll be data. So it will not actually ever duplicate itself. So I can just call this the interior volume and hit OK. And now I have a new column, interior volume, I can add here. So let's go to here, select columns, interior volume, and that will come at the very end. And we're seeing these are the vehicles in black. We're looking at the entire data table now, and these vehicles, where you see the black data there, that is where we have some volume data of the interior of the vehicle. And you're still seeing that we still have a lot of vehicles here in red. About half the data doesn't have values for that interior volume. So we don't necessarily want to use this for any type. We probably don't want to do a lot of modeling on this, or use this for any type of predictive analysis on the whole data set, because we're missing a lot of data here for what that interior volume is. We got a question on the chat here. So the name of the software, we are using Spotfire. So this is the Dr. Spotfire session. Thanks for joining. We'll be using TIBCO Spotfire throughout the session for the visualizations and exploratory data analysis. I'm seeing a couple people saying that they are seeing a blurry broadcast. Not sure why that's happening. I think some people are able to see it all right. Um, looks like the YouTube looks like I appreciate Basker saying this. So we have the YouTube channel has superb quality, and then the LinkedIn live streaming has a lower video quality. So if you're in LinkedIn, you might want to switch to the YouTube live stream. And someone did put that link on our LinkedIn group. Sachin put that. So I appreciate you doing that, Sachin, putting that link, the YouTube link in. All right. So let's continue with this. All right. So I just wanted to show, I'm not going to go through all of these missing values. You can see that this can be pretty, it could be, I wouldn't say tedious, but it could be a lot of steps when it comes to actually filling in your data and handling the missing values. But I wanted to show you some ways that you could consider, okay, well, why are there missing values? There's missing values because there's a 2-door and a 4-door, etc. Okay, so now what are some other ways you can handle missing values? There is this flyout, and you have, this is called the data panel flyout. And when I go to, for instance, 2-door passenger volume, and I go to this gear icon. This gear icon is the column properties. And let me make this a little bit bigger for you. Okay. So this is the column properties. And this shows you right here, there's so Spotfire is doing a lot of this for you. It's saying there's 743 empty values. You can do something like replace all the empty values with a specific value. So I could replace them all with 0, but I'm not going to do that because that means there's no interior volume. That there are situations where maybe you can replace that with a 0, or you do know you can replace that with a 0. You can replace with the value immediately before it in the column, or the value immediately following it. So looking at your column and looking at the rows before or after an average or a median. And there's also more sophisticated methods with hierarchical clustering, which we're going to show at the end, and that will use a Euclidean distance to impute the missing values. We'll show that at the end again as well. But this is very useful, this column properties, because we get the summary statistics here, and we get a histogram here, and we can go through and see the type of distribution we have, if it's left skewed or right skewed. Sweta's going to go into that into a second, but this is all in the data, the data column properties in the data panel. And so you can see unique values, you can see all values, you can see, all values as it goes down the column, or just the unique values. For instance, the number of gears, there's only 6 unique values. Just want to show how we handle the duplicates, and then I'm going to hand it off to Sweta to go a little bit deeper into all this. So um, if you go to our TIBCO Spotfire data function library, we have lots of free data functions available here. One that is included is identifying duplicates and removing duplicates. So these are kind of our data preparation type ones. There's also some categorical encoding, one hot encoding, things like dynamic and pivot, things like that. So I already have the identified duplicates in my analysis. And what I'm going to do is I have it in my flyout. So I'm going to go to my flyout, and I'm going to say duplicates. So duplicate identification. And this is a pretty easy data function. So this is running a script in the background, a Python script that's going to go ahead and remove duplicates. Now, if I have just duplicates in one column, I can go to this vehicle data set, and let's say I only want to look for duplicates in manufacturer. Well, there's going to be a lot of Hondas in here. There's going to be a lot of Mercedes in here. So doing a duplicate by just one value is going to, of course, bring duplicates. But I want to see if I have a duplicate vehicles across the board. So I might want to look at the model year, the manufacturer, the vision, and the car line. So if all of those combined, and maybe their index value, there's a unique index value. If all of those combined are duplicates, then I know that it's probably a duplicate record. I shouldn't have the same vehicle for that same model year. And so I'll just hit OK, and I'll hit OK. and this is going to add a calculated column to vehicle data. So I'll hit OK there, and it's added a column which we can take a look at, and that's called duplicate. So it's added this at the end. So let's take a look at our data. Let me just create a new page here and do a bar chart. And let's look at the duplicates. And then I'm going to right click and create a details visualization. That's just going to be a table. So this data that I've selected, it's a false, there's no duplicates on that flag. But this data that I select, these are all duplicate data. So this has all been flagged as true for duplicate data, and these are duplicates that I want to take out. So then all I need to do is hold that, I can go to marked rows, and then I can just delete them. And then this will delete those duplicates out of my data. And now my data is all unique. So I'm not using any duplicates in there. All right. Let's see. So, I showed that there was this this flyout. I also wanted to mention that you can click these and you can add a distribution in here. And that allows you it's a shortcut to add these distributions into your analysis and evaluate them that way. So I'm going to actually hand over to Sweta right now, who's going to talk about how you read these distributions. Sweta, do you want to go ahead and take over?
Yeah, let me just share my screen real quick. Oh, yeah, I have it up. Okay, so hi everyone. I'm going to be covering how we can visualize both univariate and bivariate data types in conjunction. So kind of like what Neil was showing before. Once we've got an understanding of our data, our different data types, as well as how much missing data we actually have. The next thing that we can start to do is study the relationships between individual data columns as well as multiple data columns. So the first thing that we're probably going to be interested in, the first thing that we're going to cover is studying univariate numerical data. So whenever we study one variable at a time, we're going to be interested in its distribution. So here, what I'm showing is the distribution of a variable called highway fuel efficiency. And it's essentially a bar chart where on the x-axis we have highway fuel efficiency, and on the y-axis we just have roll count. So we're counting all the observations to see how many times certain values occur. And when we look at this distribution, there's a couple of things that we want to be able to ask ourselves. So we're interested in the shape, the center, as well as the variation. So the way that this you can see that these bar charts tend to follow this general curve where it goes up and goes down. So the way that we describe this as its shape is unimodal. And when we describe its shape, we just try to when we describe the shape, in addition to addressing the modality, we also want to see how variable is this data. So another thing that we could also mention is the general skew of the data. So what this means is, do our data points to extend in one direction or the other moreover? So in this case, we could say that perhaps there's a little bit of a right skew because we see that there's some points that are lingering over here. But in general, it seems that this data is mostly centered. And the last thing that I would want to mention is actually the center itself. So there's different metrics of how you can measure the center of a data, but two of the most common happen to be the median and the average, which I'm sure you're familiar with. And the reason that I actually brought in another chart here is because I want to show a distinction of how two different columns or two different features can look quite different. So here we looked at a unimodal shape where the average and the median are pretty close to one another. But here, when we look at this variable called model type index, we're doing the same thing again. We're measuring its distribution, model type index on the x-axis, and on the y-axis, we have row counts. Except this time, you can see that there is generally one large collection or agglomeration of the data. So if you see my mouse, I'm kind of highlighting this general bell shape. So it's still unimodal, except in this sense, a lot of the data points are further higher on the x-axis. So if I highlight these over here, this is describing what we call a right skew. So data points are skewed to the right. And another thing that we want to mention again is the center. So the center here, when we're looking at the median average, they're pretty far off from this graph before. So the average actually tends to follow the direction of any skew that you have in a chart. So since we have a right skew in this sense, this average is actually pulled along this way. But this is why you can see that it's important to choose, you know, it's important to study different types of metrics to see which one might be most compatible with your data.
Yeah, and I'm just going to jump in there as well and say when you're saying unimodal, that really just means one peak. The modality is the number of peaks. So you might see data that is like kind of camel humped, and that has multiple modes in it or a high modality in it. If it has one hump in it, then it's unimodal. Um, and then the other thing I wanted to talk about is in terms of the histograms, people have asked before, how do I create histograms in Spotfire? And really, it's just a bar chart, but you're going to put a numerical value on the x-axis there. And you have, I guess, way to you might show this a little bit later on, like how you do the binning and how the x-axis is. But here, Sweda has on the x-axis those numerical values, and they're non-binned, so it's showing each individual value. And you have to have it non-binned if you want to draw these vertical lines on it. If you want to draw average and median on it, but if you do bin it, do you have that up by chance, Sweda? The
Yeah,
bin
it's
one?
actually on this next page right here. So you can see the distinction when you have something that's not
Okay.
binned versus binned.
Okay. Okay. Cool. So yeah, sorry, I didn't mean to jump ahead there.
No,
Um,
you're good.
Also, just wanted to quickly mention because I'm reading the chat, and some people are saying, "I don't see the FX flyout button. I don't see the FX button on my sidebar." So that FX flyout button was the button was introduced in Spotfire 11, and it really is a simplified UI for using R and Python scripts. The data functions that I showed on the community, you can still use those if you're on Spotfire 7 or Spotfire 10, you're on older versions of Spotfire. It's just you're going to have to you have to bring the file in manually. Maybe you can show Twitter if you go to data functions on the toolbar. Yeah, you go to data functions, register new, and then you hit import, and that will allow you to bring a data function file in that you downloaded from our community. I just happen to already have that in my library. Yeah, so there's a data function. Exactly. There's a Python one. And that's how you can bring it in. The FX flyout is, again, just a nicer interface that was included with Spotfire 11. Sorry, you can go on.
Yeah, no, well, I think that was a great segue because it's nice to see the comparison between the actual distributions of each variable with how a histogram looks when we tend to bin it. So the ways that this is actually created, for example, we have two histograms here of city fuel efficiency as well as highway fuel efficiency. So we can go to the data panel in the flyout. And here I've typed in city fuel efficiency. And we can just go ahead and click on it, and we can drag, or we could drag and drop these histograms directly from the flyout itself. And like I mentioned before, well, like Neil was actually mentioning, the difference between the two is that on our x-axis, we have we don't have any binning on the ones on the left, and on the right we do have some type of binning. And on the y-axis, we're always measuring row count. So this is an example, again, of a frequency histogram. There's various variations of histograms, for example, like relative frequency histograms, where you're looking at almost percentages or with respect to the whole data. But these are the ones that you tend to see most commonly. And
Yeah. And it's showing
yeah,
just like it's showing just like a typical value, right? So a typical fuel efficiency for city, which is the top right chart, the typical fuel efficiency is around 20 to 25 miles per gallon. And is it over 60 miles per gallon? Well, there looks like there's one value that's near, or one or two values near 60 miles per gallon at the far right. But once you get over 60 miles per gallon, there's no vehicles that are really beyond that. So you can see the minimum here, you can hear the see the maximum here, you can see where the majority of the data is really lying. And that is very important for understanding the nature of your parameters and your measures here. So yeah.
Yeah, exactly. And the one thing that I guess, Neil, that you also mentioned is this concept of binning. So this is actually something that we were talking about yesterday, because the way that you actually bin, or that you create these bins in histograms. So again, bins are these intervals between these adjacent numbers, essentially. So here we're actually creating 30 bins, and it's auto binning. So it's creating bins that are equidistant from one another. What's interesting is actually Spotfire has some options for binning. So here I just typed in bin, for example, and you can see various different options that we have for like bin by date time, bin by even distance, even bin by standard distribution. Although it's most common to, make perhaps auto bin and just specify how many bins you want. Um,
Yeah,
some
so I like
other,
that bin by even distance. It allows you, so like if you wanted to see uh every 5 miles per gallon as an interval, you can do bin by even distance, and then you could put in a 5 in there. I don't know if you've done that before, Sweda. Yeah, so there, and then you can put in the you have to put the city fuel efficiency, comma 5. Um,
yeah, there we go. So
and then
column name, and then how many?
yeah, and then 5, and then so there it's now evenly split into 5 mile per gallon bins. If you have the auto bin on there, so if you, yeah, you can just hit remove, and then you just click on the city fuel efficiency column, and then you, yeah, just add the city fuel efficiency column in there. And then you can check this auto bin, and you'll see that slider there on the x-axis that's right above the column name, and that allows you to kind of move these around. Now, what is the appropriate number of bins? There's a few different rules out there. There's a few different methods. I like to use, there's a method that is doing the square root of all, you do the square root of the number of data points and you round up. So there's, looks like if I look at the bottom right of Sweda's analysis, there's 857 rows. So the square root of that is around 28 or 29. And so Sweda chose, she rounded up to 30 bins. And that gives a good, a good view where there's not too many gaps between the bars like you might see on the left. But the bins are also not too wide that you lose the shape of the whole distribution altogether.
Yeah, it's kind of a balance between the two, because in this sense where we have no bins at all, we get a lot of noise. But if we have too few bins, then we're not able to see interesting features in our data.
Right.
And yeah, so Neil actually mentioned, one way that we can actually, choose optimal numbers for binning. And this is something that I was just looking into recently. And this is an article from Answer Miner. And you can see that there's various methods that have been tested just so how we can find ways to bin. So the square root is a fairly common method that looks at the total number of data points. Um, Something I also found that was kind of interesting that I was trying out was the Friedman method. So it looks at the distribution of the feature that we're looking at. So for example, it takes into account the IQR, which is again a measure of like mid-spread or dispersion. So as opposed to just looking at the number of data points, you can account for the distribution of this variable itself to figure out what's the optimal number of bins. Yeah.
All right. Yeah.
So let me just, yeah,
Hmm.
let me just check real quick if there's any questions on what we covered so far in univariate. Okay, I think that looks good. So let's move on to categorical then. Okay, so when we're trying to display univariate categorical data, we do have a couple different options. I think the most straightforward is just having a bar chart. So for example, over here, we're interested in our category for manufacturer. So you can see all the different types of manufacturers in our data set. And then on the x-axis, we just have the row counts to see how many times do these observations appear in our data set. So this is just a horizontal bar chart. You could also see it vertically as we were looking at our histograms before. And another option is being able to use a word cloud. So this is actually a mod that we have, a word cloud mod. And here we have, again, our manufacturers, and the actual sizes and the colors are have the actual sizes and colors are determined by the row count. So, GM has most common, and it's also appearing in the darkest color. So this is a kind of another neat option that you can use if you're working with either a reasonable number of categories, or you have specific distinctions between the largest ones and the smallest ones. And lastly, I thought I'd throw on a pie chart because I think these are also very commonly used in order to look at different categories. Here, what I've actually done is just limited it to the top 5 manufacturers. Although, one thing that I wanted to mention is that even though pie charts are very commonly used, it is noticeably tricky because it's hard for a human eye to distinguish between the arcs and angles in pie charts. So, for example, if I go to these labels actually, and I were to switch this off, these two look very similar. It's very hard to tell. If we go to this bar chart, we can see a little more of a distinction between BMW and the next one. But otherwise, it's quite hard to see the differences between these different sectors in a pie chart.
Yeah, I think the bar chart that you have on the top left is probably the easiest to read. You said univariate categorical. Univariate means one variable. Uni mean one, and variate for variable. So you're only looking at the distribution of one variable, and just like we did the histogram, you have right here you have a bar chart. You just turned it sideways so we could read the labels better, and we can see that GM and BMW and Famoco and Toyota are at the top. So that's really nice for when you're looking at one variable, and then I don't know if you have any tips for when we start going into 2 variables and 3 variables.
Yeah, so we're going to start looking at bivariate relationships, which again is looking at two relationships between two different types of variables. So the first thing we'll actually start off with is just bivariate numerical. So again, this means that we're looking at two variables, and they're going to both be numerical in this case. So here we're looking at highway fuel efficiency on the x-axis, and then city fuel efficiency on the y-axis. And the most common chart to display bivariate numerical data is going to be a scatter plot. So here we just have a plot for every single observation, or we could take perhaps like the average of observations at a certain location too. And so here we just see actually that it follows a general positive slope or positive correlation from, as Neil was mentioning before. And there's a few interesting things that we can do on top of this. So you might notice that while most of the points are kind of clustered, in this general region, there are some points that are fall away from the spread. So one thing that we can actually look at is how we might be able to identify potential outliers. And I'll show a couple different methods. One thing that we can do is go to this color scheme. And let's say that we're interested in looking at outliers in our x-axis direction, so for highway fuel efficiency. So if I color by highway fuel efficiency, I can go to make sure it's fixed as a gradient, and then choose this option to exclude outliers. So this automatically detects these 4 points in white as outliers because they're either less than a lower inner fence threshold or above an upper inner fence threshold. And this is something I was going to mention later, but these are two statistics that are essentially computed based on the spread of your data. So they look at where does, where is the center of your data? Where's the first 25% of your data and the later 75%? And how do these points fall away from these metrics essentially? And so this is one way that you could use color directly within Spotfire itself. And another way that you can actually do this is by creating a calculated column. And this is actually also where you can go ahead and perhaps like tweak outlier metrics for your own interests. So over here, Neil has actually defined this calculated column for highway outlier. So it's actually the same thing essentially. We're defining anything as an outlier if it's above the upper inner fence or if it's below the lower inner fence. And of course, you can tweak these metrics too if you want to. But this would be a good way. Now that we've created this column for if something is an outlier with a true or false Boolean value, you can actually go ahead and perhaps like remove the true values. But it does the same thing in terms of the visualization.
Yeah. So, oh, there you go. That looks great. Yeah, so now you can actually color it by that column. Another thing you could do is you could filter out any of that data. Um, so if you wanted to take out anything where the highway fuel efficiency was an outlier, you could add a transformation here, and you could go to filter rows, and you could filter out highway fuel efficiency, or outlier equals false. But what that's going to do is remove the entire rows there. So yeah, that's one way you can do it. Um, that's going to remove the entire row. The other thing you could do is you could use the same type of expression, and you go to calculate and replace column. So right there on transformations, no, right there where you were, um, you could go to calculate and replace column, and you could use that expression. I don't know if we have that expression. Well, we'll just say that expression. I don't want you to have to type that whole thing out. Um, but you could use that expression in this, and then whenever there is maybe it's actually easier if I show it on mine later. But what you're able to do is you can substitute a null value in when there's an outlier, and just keep the values in when it's not an outlier. And that allows you to look at just the data that's not an outlier, that's inside your interquartile range. And why you want to maybe be concerned with outliers, in this example, we're just kind of showing how to find outliers, but outliers could start to skew your data and it could affect your models. If you're really trying to see, for instance, how a typical vehicle performs, and you have these 4 or 5 vehicles on the top right that are shown, that have these extreme points that are really atypical of a normal vehicle, then it's going to be hard to build a model for how vehicles perform. Oh, it's not going to be hard, but it's going to affect the model that you build for how a vehicle performs. So you might want to exclude those out to improve the quality of your model. Um, and then I do see a question. I just want to throw this on here. So Jeff was asking, will a recording of this be available after it completes? And yes, this will be on YouTube immediately after it completes. So the Spotfire YouTube channel is where you can find this. And we also had a question while you were chatting there, Sweta. Someone wanted to know where the word cloud visualization was. And thank you, Ahmed, for answering. That is at tipco.com. There's a word cloud mods. A shortcut to that is you can go to tipco.com/mods, and there's a whole page of different custom visualizations that you can use. Okay, so sorry to interrupt there. Just wanted to pop in and
Yeah, no problem.
yeah.
Yeah, that's great because outliers are, an essential topic. They come up when we're, again, studying or being able to explore the distribution of our data, or just being able to better understand it. So that again comes into relationship. That again comes into play when we're looking at any one or more variables. And right now, again, we just covered kind of bivariate numerical. So I'm going to jump tabs and look at how we can study bivariate. Well, I called it bivariate categorical, but we're actually going to see here is how we can look at one numeric variable and one categorical variable in one visualization, and also how we can look at two categorical variables in one visualization. So this chart on the left over here is what we called it's a bivariate chart again, but on the x-axis we have fuel usage, which is going to be a categorical variable, and on the y-axis we have highway fuel efficiency, which is a numerical variable. And a common visualization in order to be able to see this is going to be a box plot or a box and whiskers plot. So what it essentially does is it splits apart this categorical variable in its various categories, and for each one of them, we have this box and whiskers diagram. And this is actually, it's great that we're actually segueing from outliers, because I think this is a perfect tool in order to both be able to find outliers in your data, as well as just get a general comprehension of like summary statistics. So what a box plot, or let's just focus on one of these, for example, what these box plot shows is, it shows the overall distribution of your data. So if we start in this section over here that I'm highlighting, you can see that there's this thing called like Q1 median. There's also something called like median Q3. So as I mentioned, each one of these box and whiskers plots is going to be representing some of those summary statistics that we saw from before. So we are kind of already familiar with what our median is. It's a familiar measure of center. You order your data from smallest to largest, and then you find whatever's in the middle. So if the median point falls above 50% of your data and falls below the other 50%. Q1 refers to the first quartile, and in a similar way, it represents the point in your ordered data where you're above 25%. And Q3 represents the point where you're above 75%. So this is again ranking and being able to pinpoint these points that measure the spread of our data. And
So
so
you're
here
able
we
to
can,
see where the right where the middle 50 percentile, the middle half of your data is all right there in those boxes, right? So half of your data is in that boxes, and then the rest of the data, the edges of the data are in the line and the points, right?
yeah, everything from Q1 to Q3 is going to be within these two boxes, and you see the rest falling into these two like whiskers over here. So what fall into the lower adjacent value and the upper adjacent value. And anything that kind of falls in these circles over here is what we mark as outliers. And it's by those same metrics before the UIF and the LIF.
Yeah. And I also wanted to mention that you can visualize the distribution here. So if you go to the settings and then you go to appearance, there is a show distribution check mark under transparency. And that actually shows you this is like the histograms that we were just looking at, but turned on its side. And so you can actually see how the shape of your data looks and overlay it that way.
Yeah, and actually, while we're here, there's a couple other things that I like to add on. One of them is to show either the comparison circles or be able to identify the 95% confidence intervals. And another thing that I actually added on to this visualization was from our statistics table. So you can add some of these additional metrics that we were talking about before, such as the upper inner fence and not sorry, and the lower inner fence. But these are good measures of identifying the thresholds for outliers and also being able to see just how many we've identified in general.
Right. And I also wanted to tack on there. We had a question about is there a situation where outliers can be useful in analytics? And can you please share an example? I think in the last page I was saying, oh, well, here's how you can just find the outliers that are above and below the upper inner fence, lower inner fence, and you showed that nicely with the color scheme and the expression. But you don't necessarily just want to throw away all outliers, especially if you're working with like very sensitive data, and if you're doing anomaly detection. And we did a session on that recently where the value is actually in the anomalies you're looking for, are actually in the outliers often.
Yeah, exactly. I will also add on to that to say that um, d- data points, if ever removed from a model, are done so with extreme caution. A lot of the times outliers can provide, a lot of information. Um, it's not just, it doesn't tend to be a matter of human errors all the time. You can perhaps do separate modeling if you find a group of outliers, or they could be indication of some type of interaction in your data that you might not be accounting for.
Right. Exactly. And just looking at the time here, so we have about 10 minutes left. Maybe we want to move on to some of the cool data relationships and the shortcut ways to this. One of the first questions was how we can automate some of this analysis and automate the way we do this. And I think the data relationships tool is a great way to do that.
Yeah, so that's actually what we were about to jump into. And that's a great question because a lot of what we've shown is studying, well, exactly one or two variables at a time. But the question is, how can we get a general sense of all these trends in a quick manner? So if we go to date tools and then data relationships, um, we can go ahead and choose our data of choice, vehicle data, and then be able to calculate different types of comparison methods that essentially you can run over all columns in your data. So for example, linear regression is good if you want to study numerical variables against numerical variables. You can also run like Spearman R, which is a correlation method, ANOVA, Kruskal-Wallis, and chi-square. In general, we actually have a quick cheat sheet about when and how you can use these different types of methods. So again, we've broken them into their different types of categories, and then also thrown in the corners of a general description of how they function. So we split them up into parametric and non-parametric methods. So to give a quick high level, parametric methods just tend to assume that the data is normally distributed and that it follows a certain types of distribution from its population distribution. So they do assume something about the data, while non-parametric methods don't necessarily have an underlying distribution assumption. So if we go back to here for the data relationships, you might remember from before that one thing I was studying, for example, was the scatter plots of just two fixed variables at a time. So if we go here, we can actually click, for example, linear regression. And over here, we have just all our integer and real variables. And what I want to do is just go ahead and select them and add them in as Y columns, and then do the same for these on our X axis. So what I've already actually pre-run these here before, but this is actually super fast to run. As you can see, that just appears here. So we'll skip over the ones for which there was like an invalid linear regression, but let's look at the ones where we're getting some results. So again, we're running a linear regression across all of our variable pairings. And this is quite helpful again because we're able to study the correlation between these data and just to look at all our scatter plots as we tend to zoom through this.
So in the very beginning, I was talking about weak correlations, strong correlations, positive, negative correlations. You're starting to see here, these are actually arranged in order of the strongest correlations, and they can be positive or negative. It doesn't matter. You're just trying to see a relationship. But it's showing that R squared value around where Sweta, yeah, right there, R squared value, and it's arranging it. So you can see city fuel efficiency like and engine displacement that she has selected right there. There's a strong relationship where the higher your engine displacement, which is really the larger your engine is, the worse your city fuel efficiency is going to be. It's negatively correlated, but there's a pretty strong correlation there. So this is actually doing all of those pairwise comparisons for you all at once, and you saw that just took a couple seconds to just select all the columns, and now you can just cycle through them.
Yeah. And while I run that, one thing that I actually added on to that same page was being able to actually visualize this correlation matrix right here. So here I'm actually like I'm fixed on one of the values that has a pretty high correlation of 0.98. So you can see that in a darker purple color. But when we read this correlation matrix on our diagonal, it's just all the variables with itself. And on the off corners, we can see exactly which variables have perhaps the highest correlations. We can jump to them if we want to.
Yep. So that's just using a heat map visualization. Pretty simple. If you want to pop that out real quick, Sweta. Yeah. So
Yeah,
you do a heat
so
map. Sorry. Go ahead.
yeah, I was gonna say, yeah, it's a heat map visualization, and then just we have our x and y on both of the axes. You can switch them, however, and it's just the average R or the Pearson correlation coefficient for the measure of each cell.
There you go. So that's a really easy way to see which variables are highly correlated, and why might that be important to see which variables are highly correlated.
Well, we could be interested in knowing which variables we want to perhaps include or exclude in our models, because often variables that are highly correlated, depending on the model that we choose, again, we might want to include them. But if there are certain types of interactions, that's also something we can maybe account for.
Right. All right. Do you have some examples with categorical? And then I'll have a few things to show on clustering and stuff we might be actually going over time today.
Yeah, yeah, no problem. So, in terms of categorical, there's actually a couple of data relations that I've also run in the background. It's the same general type of idea. You're selecting data relations, and then you can choose. In this case, I chose to run ANOVA. So in ANOVA, you can essentially think of it as a variant of linear regression, except on our x-axis, we're going to be studying some type of categorical variable. So here you're seeing all pairwise box plots with categorical variables on the x-axis and all numerical on the y. And likewise, we can get different types of measures for our summary statistics. And the last thing I also want to mention is chi-square, because this is looking at categorical versus categorical, which we kind of skimmed over before. But essentially, One of the visualizations that we can get from this is a cross table or perhaps even like contingency tables. And here we have any type of categorical variables on both axes. And the cells themselves measure the number of observations and are colored by where they're max. So the chi-square actually tests for whether there is a relationship, or they tend to say, are these two variables independent or not? And ANOVA tends to test for whether the means or the measures of interest across these different categories. Sorry, let me choose one that has reasonable numbers. Whether these means are different from one another or not. So this is determined again from those p-values.
Nice.
Yes. So that's a quick overview of data relationships right there. Let me hand it back to you, Neil.
Yeah, no problem. Thank you for showing that, Sweta. So we have univariate distributions, bivariate distributions. We were able to see relationships and correlations between those distributions and well, between those variables. And what about if you have more than two variables? So Spotfire is actually very good at doing multivariate analysis. So I have a few quick examples here on showing. One is a heat map. So we've been talking about heat maps. This allows me to show three different variables. So I have a car line class, a type of vehicle. We have compact cars, large cars, mid-sized cars, station wagons, all the way up to vans and trucks and sports cars. And then you have the manufacturer, Aston Martins, Audis, Bentleys. You have a lot of sports cars in here, as well as commuter vehicles, things like that. And what do we want to visualize this by? Well, we're using highway fuel efficiency here. I could switch this to see what are the number of cylinders in the vehicle. So this is really red here. This is the lowest. The Mazda has the lowest. The highest is over here. This is the Bugatti. The Bugatti two-seater has the highest number of cylinders there. So we're able to kind of see this distribution or see this type of data spread across multiple variables. But how do we bring that together? And that is using hierarchical clustering. So in the heat map, if you go into properties and you go into dendrograms, you can actually create row dendrograms. I'm going to show some row dendrograms and I'm going to hit update. And this is actually going to cluster my data into similar type data. And I'm going to do this for the rows and I'm going to do this for the columns. So I'm going to explain them together. So I just updated that for the columns. There are these settings for the clustering methods, and I'm using the Euclidean distance and I'm using the UPMGA, which is the unweighted. Let me see if I can first explain this, and then I'll explain what those parameters are. So we see these leaves and these so you have these leaves and these nodes here. So all of these vehicles in terms of manufacturers are pretty similar, and then these two are standing out quite differently. The Volkswagen and the GDX are standing out pretty differently as a lot of so this is very high on highway fuel efficiency. These vehicles are also going to be your compact cars, your small station wagons, special purpose vehicles. The vehicles, if I wanted to say, okay, well, that's nice, but there's a lot going on here. That's not really telling me which of these are similar. I could actually come down to another level in this and say, okay, well, these vehicles are pretty similar. And of this split, then these vehicles are pretty similar. So this is now my pickup trucks as well as my two-seater sports cars and compact cars. So we're seeing Lamborghinis here, we're seeing Land Rovers here. These are some of the worst vehicles in terms of highway fuel efficiency. Maybe fun to drive, but this is showing that those not only are these manufacturers going to be worse in terms of highway fuel efficiency, but these type of vehicles are worse in terms of highway fuel efficiency. So we're breaking that out. Um, I did say, like, let's see if I can show this now. So, all right, the hierarchical clustering similarity calculations. So I used a distance-based method, and what that's doing is it's looking at all of these different variables. I have variables A, B, C, D, and E that it could be used. Right now, I've just used three, which is the manufacturer, and I'm looking at the manufacturer, the compact car, the car line, and the I'm looking at the highway fuel efficiency. And what it's doing is saying, how do I bring which of these across these three parameters are closest together? And it's categorizing it that way. That's using a Euclidean distance method. There are different Euclidean distance methods that are available in hierarchical clustering. There's also the city block, which actually goes in a kind of a square fashion. And then there is shape-based methods, which are not going to look at how close are these points to each other, but what is the profile they follow. So something that might have high highway fuel efficiency, low number of cylinders, high passenger volume, um, that might be one shape, and another vehicle might have the same type of shape, but it could be shifted lower. It could be a much smaller vehicle, a much different vehicle in other areas, but in those three areas we're looking at, it matches that profile. So this is kind of a profiling method as well. Um, so those are the different methods. And so you can see that in your properties, and you go in again into dendrograms and settings. You can choose your Euclidean distance, the city block, the square Euclidean, the half square Euclidean. Those four in the bottom are your distance methods, which are trying to find which data points are closest to each other. And then the first three are your similarity, and those are trying to show what is the profile across these. So you can play with those. And I also mentioned that you can use this to actually, let me see if I can go here. You can use this to actually fill in empty values. So there are no empty values in this data, in these uh, variables that I'm looking at. But if I had some empty values, for instance, for highway fuel efficiency, it could actually, instead of just filling in with an average, it could be looking at the nearby data points and using a Euclidean distance hierarchical clustering method and filling in the data points with the nearby data in terms of the parameters that I gave it, if that makes sense. Okay, so that's one way. And then there's the parallel coordinate plot. The parallel coordinate plot is another chart where you can add different um, variables. Right here on the bottom, you're seeing this axis change. And so if I want to see, for instance, I have number of gears, I have number of cylinders, I have highway fuel efficiency. I want to see all the vehicles that have high highway fuel efficiency. I can grab that. It looks like this has a lot of vehicles that have a few number of cylinders here, and have the smaller engine displacement. We're seeing that similarity there. And if I wanted to see the ones that had low highway fuel efficiency, let's say some of these that are down here, we're seeing that these have larger engines, right? So they have more gears, they have more cylinders, they have larger engines. So that is another way I can look at multiple variables together. So this is actually like a scatter plot, but it's a scatter plot with four different axes now. And you can add more axes to this as well by going to your settings and choosing your columns here. So I can choose, transmission type, for instance, and add that in there, the transmission type, and just keep adding those in there. Um, and then another way you can look at this is k-means clustering, so which is really more of a modeling operation. But with clustering, we can look at similarity on these. So for instance, I had those same four here, and I can right click and I can say, oops. So the way you set up this chart is you select your columns, you do a line chart, and you select your columns, and you put your columns into your y-axis, and then you just put column names into your x-axis, and that'll look just like a parallel coordinate plot. And then I already have the k-means clustering. I think I had already set this up. Let's see. Yeah, right. So you right click it, you can do k-means clustering. It'll ask you how many clusters you want to do. There is a data function on our exchange called the done index, and that done index will give you the optimal number of clusters. I wanted to show that today, but we are running over time, so unfortunately I'm not going to show that piece today. But I'm just going to say create this where there's 5 different clusters, and do this by Euclidean distance. So remember, we have the similarity method, which is a profiling, the correlation, or we can do Euclidean distance. And I can say do it by Euclidean distance, and that's going to create 5 different clusters for me. So we're seeing clusters where Let me go ahead and create a details visualization. That's a table so we can read some of this. So if I select these that have a high number, a highway fuel efficiency, and they have lower on the engine displacement, we're seeing that this is these Mazdas, these Fumoco Mazdas, they're all, looks like all hybrid vehicles here. So this actually pulled in all four-wheel drive hybrid vehicles on its own. It found that all on its own as a cluster. We have, let's see if I pull this over to the right here. This one has this is a whole another class of vehicles, and this looks like BMWs and Porsches, Toyotas, so things like that. Um, Last thing I'm going to do to wrap up here. So we showed all of these different steps. Now Spotfire will do a lot of this for you. Uh, we showed the data exploration tools, but if you are just going to open up an analysis, this is probably one of the things we could have shown at the beginning, but we wanted to show the power of all the different data visualization, exploratory data analysis that you could do, and then show you the power of like having that at your fingertips. So if you select in your data panel and you go to this light bulb, you can actually see, for instance, if I do highway fuel efficiency that we've been looking at, we can select this as a target variable. And what this is finding is a relationship with the other data. And so we're selecting what variable that we're interested in, and it's going to tell us what other variables are highly correlated with it or helping to predict it, what the other predictors are, and we can just add those to our analysis. And this actually ranks it by the strongest relationship. So there's a relationship with the gas guzzler status. There's a relationship with city fuel efficiency. So if I click that, we're seeing highway fuel efficiency and city fuel efficiency are highly correlated. We saw that with earlier with Sueda's data relationships tool in the pairwise. Well, this found that as well, just right from the flyout. It's also found relationships with a categorical variable, such as that gas guzzler status. So is a gas guzzler, is it an exempt status or not? We can see something here with the engine displacement, something else that's come up repeatedly. So when I click engine displacement, now we're seeing a relationship with highway fuel efficiency. With higher highway fuel efficiency is lower or smaller engines, things like that. So I encourage you to use this AI recommendations. If you like the relationship that you're seeing, but you don't like the chart, you can also click more like this. And then that will show you, for instance, a density plot, heat map, scatter plots. It'll show you the same relationships in different charts. And this can be a super quick and shortcut way to explore your data and create the initial visualizations that you need before you go on to then create a deeper analysis. So with that, I will look at the questions, and let me bring Sweta back on here. And let's see, do we have any questions? So we saw someone with a move away from R and Python and Spotfire, more internal functionality. We're actually going more towards using, so there's a question here from Gregory. Let me pull up. Has there been a move away from using R and Python functionality and Spotfire to more internal functionality? So we showed a lot of the internal tools today, but we are actually going more towards the R and Python functionality and making that feel like an internal experience with a data function flyout, right? So if we can have it where this feels like an internal tool, but it's something that you can build yourself. These are all different data functions that you can use, and it feels like it's just part of the tool. That is kind of the direction that we're going.
Yeah, just to add on to that, so like data functions are meant to be no code customizable, so you can drag and drop them to use them in addition to Spotfire features. But they're also available for analysts to modify them to any degree if they want to. So it's almost like changing these inner functionalities.
Right. Rather than having it all locked into the product, it's like you have the flexibility to change it if you want, or you can just grab one off the shelf and use it as it is. It looks like that's it for our questions. So thank you all for joining today. Thank you, Sweta, for your presentation as well. And we're going to see you again in just about a month for our regression analysis and regression methods talk, right?
Yep. Yeah, thank you everyone. So look forward to next month, and thanks for joining us on this EDA session.
All right. Thank you, everyone. We'll see you next month. Have a good one. Have a good week. Bye.